Hello. Today we're going to be talking about how to take the derivative of a function using the limit definition of the derivative. The limit definition of the derivative is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. The function that we'll be looking at today is f of x equals x squared plus x. Now the first thing that we want to do to find the derivative of f is we want to simplify this, what's called the difference quotient, first. Once we simplify the difference quotient, then I'm going to hit it with the limit as h goes to 0. So the first thing that I want to look at is f of x plus h. F of x plus h, everywhere I see an x, I'm going to replace it with an x plus h. So that's x plus h squared plus x plus h. Now, I want to expand this product here. I want to expand this. So this is going to be x squared plus 2xh plus h squared plus x and then plus h. And there are no like terms, so I am done writing out the f of x plus h. The next thing I want to do is I want to look at what is f of x plus h minus f of x. So I'm going to rewrite my f of x plus h. So that's 2x squared plus 2xh plus h squared plus x plus h. So I've rewritten my f of x plus h. Now I want to subtract off the f of x. Now we are subtracting the entire f of x. So I'm starting with the parentheses and rewriting the f of x. So that's going to be x squared plus x. And what we should notice, actually what I'm going to do next is I'm going to distribute the negative to the f of x. So this is x squared plus 2xh plus h squared plus ax plus h minus x squared minus x. And so what we should notice here is that the x squares have like terms and they cancel out. We should also notice that the x's cancel out. And so we are left with 2xh plus h squared plus h. And so that's what we have. We have 2xh plus h squared plus h. And so the last thing I'm going to do to simplify this difference quotient is I'm going to look at f of x plus h minus f of x all over h. That's the last thing. That's the next thing I'm going to look at. So I'm going to rewrite my f of x plus h f of x plus h minus f of x that I just simplified. So that's going to be 2xh plus h squared plus h. Now that I've written my f of x plus h minus f of x, I'm now going to divide it by h. So I'm going to put a big division, h. So then the next thing I'm going to do is I look at the top, and it has 3 terms, 1, 2, 3. And in each one of those terms, h is common. So I'm going to factor that out and get h times 2x. So I factored out the h from there, and I'm left with just the x, 2x. And then plus h. I factor out one of the h's, but there's still one left. And then don't forget plus 1. Because again, I should be able to multiply the h inside here and get back what I started with in the numerator. And then, again, I divide by h. And what we should notice is the h's can cancel. So I'm going to cancel out these h's. And I'm left with, so finally, okay, I have 2x plus h plus 1 all over, sorry, not all over, just that's it. So they canceled out. I'm left with just 2x plus h plus 1. Again, my ultimate goal is to find f prime of x. What I did here is I simplified this quotient. Now, in order to find f prime of x, I need to send h to 0. So I'm going to evaluate. So I have f prime of x equals the limit as h goes to 0. I'm going to rewrite my reduction. So I went from f of x plus h minus f of x all over h is the same thing as 2x plus h plus 1. So 2x plus h plus 1. And so to evaluate this limit, I'm going to replace all the h's with 0. So that equals 2x plus 1. And so what we have here is, given f of x equaling x squared plus x, the derivative of that is 2x plus 1.